IBESS, Water and Aquatic Food Production, Part 7, will be the first of 2 movies on aquatic food production. The movie introduces basic concepts and ends with bad news, dwindling fish stocks, and damage to habitats. The significant ideas are: aquatic systems provide a source of food production, and secondly, unsustainable use of aquatic ecosystems can lead to environmental degradation and collapse of wild fisheries. Here is the first of 2 slides displaying the outline of the movies available in the Water Aquatic Food Production Unit. Use this slide and the next to find the movie you need for review. This movie is found on the next slide. Here is the second slide outlining the movies available in the Water Aquatic Food Production Unit. Use this outline to find the movie you need for review. This movie is focused here. Here are the first IB syllabus statements to kick off this movie. Photosynthesis by phytoplankton supports a highly diverse range of food webs. Aquatic, freshwater, and marine flora and fauna are harvested by humans. Phytoplankton are small, single-celled organisms that photosynthesize. Phytoplankton are the producers of aquatic ecosystems. Phytoplankton provide the energy for aquatic food chains and food webs. Phytoplankton are eaten by zooplankton that are eaten by small fish and larvae of fish that are eaten by larger fish. Phytoplankton are the producers of aquatic ecosystems. Phytoplankton provide the energy for aquatic food chains and food webs. Aquatic food webs are diverse and complex. Phytoplankton and macrophyte algae, the seaweed, are the producers of marine and freshwater aquatic ecosystems. Now that you've been introduced to the producers and the consumers of aquatic ecosystems, don't forget the decomposers, whose habitat is the sea floor. They provide nutrients to the water, nutrients that are then available to the producers. Nutrients are highly concentrated deep near the sea floor, but there is no light at depth. Nutrients are often in scarce supply near the surface where there is light. Locations where currents move nutrients from depth to the surface are locations of high photosynthetic productivity. Humans harvest both flora and fauna from aquatic ecosystems. In this photograph, we see fauna, fish, being harvested. From the ocean, humans harvest mammals, fish, crustaceans, and mollusks, including squid and shellfish. Humans also harvest flora, seaweeds, macrophytic algae. These are the producers of aquatic ecosystems, along with phytoplankton. In these photographs, you can see humans harvesting various species of seaweed from the ocean. In addition to eating seaweed, humans incorporate seaweed into many products, such as soaps and shampoos and toothpaste. Carrageenan is a seaweed product that adds a creamy consistency to various products. Carrageenan from seaweed is found in many products that we consume. And if you're surprised about your daily consumption of seaweed, consider changing societal attitudes towards health foods and food fashions. People are constantly looking for innovation and change. Our food habits are changing as quickly as our personal device technology. So as you think about aquatic food production, consider changing attitudes towards health foods and food fashions. Of the total protein consumed by people in grams per person per day, protein provided by fish is relatively low worldwide and on any continent, as you can see here, 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 and here. But aquatic food production could increase with aquaculture. So let's refocus with a new IB syllabus statement. The highest rates of productivity are found near coastlines or in shallow seas where upwellings and nutrient enrichment of surface waters occurs. The continental shelf is a region of shallow water just off the coast. And as a shallow region of water, light and nutrients are both available to stimulate high rates of primary production. Off the southwest coast of Africa, you can see the high levels of chlorophyll along the coastline. High levels of chlorophyll indicate phytoplankton and high rates of productivity that occur over the shallow continental shelf. The shallow continental shelf is nicely seen in this diagram. The shallow water allows light and nutrients from the seafloor to stimulate productivity. The productivity of the continental shelf region has resulted in political boundaries that establish territory. The territorial waters, as defined by the 1982 United Nations Convention on the Law of the Sea, is a belt of coastal water extending out about 12 nautical miles from the coast. These territorial waters are regarded as the sovereign territory of the state. The exclusive economic zone is a zone over which the country has special rights regarding the exploration of the area and use of marine resources, including energy production. It stretches from the coastal edge out 200 nautical miles. The international waters have no sovereignty, as no state controls them. All states have the freedom of fishing, navigation, overflight, cables, pipelines, and research. Upwellings are regions where nutrient-rich cold water is moved toward the ocean's surface. The nutrient-rich water stimulates the growth of primary producers such as phytoplankton. Due to the biomass of phytoplankton, upwelling areas can be identified by high concentrations of chlorophyll. The increased nutrient availability in these upwelling regions results in high levels of primary productivity and thus very strong fishery production, as you can see here. Approximately 25% of the global marine fish catch comes from 5 upwellings that occupy only 5% of the total ocean area. The rotation of the earth and winds help maintain the flow of ocean currents, along with regional temperature and salinity differences. One more time, ocean currents occur because of regional differences in temperature and salinity, along with wind and the rotation of the earth. Currents include the movement of nutrient-rich, cold water toward the ocean surface. The nutrient-rich water stimulates the growth of phytoplankton. You can see in this diagram how surface winds assist the push of surface water, allowing the cold, nutrient-rich water to well up to the surface, bringing with it high levels of productivity. At this point, you should be able to define upwelling areas and state their importance to ocean food webs and human fishing. 500 million people make a living in ocean fisheries. Approximately 10% of total protein consumed by people comes from fish, but this figure varies widely from greater than 30% in Japan to less than 1% in some inland areas. George's Bank is located between New England and Nova Scotia, and it's one of 2 historic wild fisheries that comprise the continental shelf off the coast of North America. Its depth is just several meters to several dozen meters more shallow than the Gulf of Maine. George's Bank is probably the most geographically accessible of all the fishing banks in the North Atlantic. George's Bank is single-handedly responsible for the economic development of coastal fisheries in New England. For over 400 years, George's Bank supported lucrative fisheries for Atlantic cod and halibut. But over time, bottom trawlers were catching as much cod in an hour as traditional boats caught in a season. However, bottom trawlers damaged the seafloor, so federal fishery regulations were developed to control this large-scale overfishing so that they could establish future sustainability. The Grand Banks of Newfoundland are a group of underwater plateaus southeast of Newfoundland on the North American continental shelf. Notice how shallow this area is. These areas are shallow, and the cold Labrador current mixes with the warm waters of the Gulf Stream right here. The mixing of these waters and the shape of the ocean bottom lifts nutrients to the surface. These conditions help to create one of the richest fishing grounds in the world. Fish species include the Atlantic cod, swordfish, haddock, and shellfish, including scallops and lobster. The area also supports large colonies of seabirds and various sea mammals such as seals, dolphins, and whales. So let's transition with these two IB syllabus statements. Demand for aquatic food resources continues to increase as human populations grow and the diet changes. Secondly, define wild fisheries. Let's start with the definition. Wild fisheries are sometimes called capture fisheries. The aquatic life they, capture fisheries, support is not controlled in any meaningful way, and thus the life needs to be captured or fished. Wild fisheries exist primarily in the oceans, and particularly around coasts and continental shelves. Wild fisheries also exist in lakes and rivers. In this graph showing fish production, over time there is much to explore. Notice the increase in the size of the human population shown as the orange shading and quantified along this axis. Notice how the total marine catch from wild fisheries, seen as the blue dotted line, levels just below 100 million tons in the early 1990s. So the human population continued to grow while the harvest of wild capture fish leveled. This would translate to a declining per capita fish consumption. But per capita fish consumption remains level, and that's because aquaculture has increased to make up the gap. Aquaculture has filled the gap between a growing human population and a leveling of wild capture fish. More on aquaculture in Part 8. This graph shows the global wild capture fish production and shows the energy invested by fishermen to capture fish in the open ocean over time. The quantity of wild captured fish leveled off despite an increasing amount of energy invested by fishermen. The fishermen were fishing harder but not getting more for their effort. The oceans were being overfished. So that brings us to this statement. Developments in fishing equipment and changes to fishing methods have led to dwindling fish stocks and damage to habitats. With traditional technologies, rates of harvest were low. Harpoons, fishing rods, hand-thrown nets were subsistence living technologies. But developments in fishing equipment and changes to fishing methods have led to dwindling fish stocks and damage to habitats, from hand-thrown harpoons to harpoon guns, from fishing rods to massive nets. So here's a relevant IB syllabus statement. Consider how two different fisheries are managed for sustainability or lack of it. Refer to improvements to boats, improvements to fishing gear, such as trawler bags, and detection of fisheries by radar. Capture fishery technology has changed dramatically. This is fishing on an industrial scale. The ships, the nets, the instrumentation such as radar to find the schools of fish. This is industrial fishing. Pressure on fish stocks comes from fleets of boats, many boats with modern refrigeration and technology to track schools of fish. Developments in fishing equipment and changes to fishing methods have led to dwindling fish stocks and damage to aquatic habitats. Sonar and satellite technology inform fishermen of fish stock location. Massive nets put stress on the fish stocks, but also the nets are indiscriminate nets, in that many unintended species are caught and thrown back dead. Bycatch, as it's called, such as this shark, are unintended species caught in indiscriminate nets. Bycatch fish are often thrown back dead. With large fleets, satellite technology, and massive indiscriminate nets, the rate of capture has exceeded the rate of replacement. Ocean fish stocks have dwindled. With large fleets, satellite technology, and massive indiscriminate nets, the rate of capture has exceeded the rate of replacement. Ocean fish stocks have dwindled. Atlantic codfish harvest climbed rapidly shortly before 1970 and peaked at over 800,000 tons. After 1970, the harvest experienced a sharp decline. After a small rebound, the wild fishery collapsed in 1992. This is just one example of many oceanic fish stocks that appear to have collapsed. New England ground fish production, the amount of fish brought to market, halibut particularly, declined after the 1980s. Pacific bluefin tuna catch declined from the 1950s into the early 2000s. In the 1950s, out of 100% of the world's fisheries, most were underexploited. But by the 1990s, most of the world's fisheries were overexploited if they hadn't already collapsed. In 2003, the stock of various fish species were well under the minimum recommended size for sustainable fishing. In the UK, the number of fishing boats in 1937 is approximately the same number of boats in 2008, but the cod catch went from 350,000 tons in 1937 to 19,000 tons in 2008. The rate of capture has exceeded the rate of replacement. Ocean fish stocks have dwindled. The majority of wild capture fish caught by humans on the y-axis are the open ocean pelagic species, seen here, and those that live near the bottom of the ocean, known as demersal marine fish, seen here. So that in recent times, the majority of fish, wild capture fish caught by humans, are the open ocean and demersal species. Now keep in mind that humans harvest many different species from the ocean: mollusks, crustaceans, and plants. Now the large quantity of fish harvested near the bottom, known as the demersal marine fish, leads me to the last section of this movie. As we bring this movie toward its end, I've come back to this syllabus statement to focus on damage to habitats. The damage has happened at the ocean bottom, where fishermen trawl the bottom for the demersal fish. Developments in fishing equipment and changes to fishing methods have led to dwindling fish stocks and damage to habitats. Bottom trawling, seen in these images, is a technique using a large net with metal gates or doors. The net, about a half-acre wide, is dragged along the bottom, scooping up halibut, cod, and other bottom-dwelling fish. In this diagram, you can see the net being dragged by the boat, and you can see how the net scrapes along the sea bottom, damaging the sea bottom habitat. Here is an image of the metal gate or door with the net just behind. The metal gate holds the net down on the bottom and scrapes along the sea floor. Here are photographs from Carrageenan Bay in Wales before a bottom trawler and after. You can see the change in the habitat. You can see the damage to the habitat. In this bottom photo, you can see the marks left on the sea floor by a bottom trawler. In this top photo, which is an image from a satellite, it shows the trawling scars on the sea bottom in the Wadden Sea off the coast of the Netherlands. As you look at another satellite photo of trawling scars on the bottom of the Wadden Sea off the coast of the Netherlands, this is the IB syllabus statement that I've been working to cover. Developments in fishing equipment and changes to fishing methods have led to dwindling fish stocks and damage to habitats. And that brings us to the end of IB ESS Water and Aquatic Food Production Systems, Part 7.